Hello, dear students. We are going to solve some numerical problems related to X-rays. At first, let us review the related formulas. If V is the potential difference between anode and cathode, then the energy of electron, kinetic energy of electron striking the anode or target is given by the relation E into V is equal to half mv square, where m is the mass of electron and v is the velocity of electron striking the target. Second formula, cutoff wavelength of X-rays is given by the relation lambda minimum is equal to hc upon E into V, because the values of h, c and E are constant. Therefore, on simplification we get the lambda minimum as 12,400 angstrom upon V, where V is the potential difference between anode and cathode. Third formula, Bragg's law, 2d sin theta is equal to n lambda, where n is order of reflection and d is the interatomic spacing, also known as lattice spacing. Here theta is glancing angle. First question is, an X-ray tube works at a DC potential of 50 kilovolt. Only 0.4% of the energy of electrons or cathode rays is converted into X-rays, and heat generates in the target at the rate of 600 watts. Estimate the current passed into the tube and the velocity of electrons striking the target. Mass of electron is given to be this much. Solution here given. Heating power, suppose this is P, heating means H, 600 watts. 0.4% of energy of electron striking anode converts into X-rays. This means that this heat is due to 99.6% of total electrical power. Potential difference is 50 kilovolt. Kilo means 1000, so it is 50 into 10 to power 3 volt. We have to find the current I, and secondly V. V means velocity of electron. Velocity of electron striking the anode. So solution, first, according to question, heating power, which is PH, will be equal to 99.6% means upon 100 of total electrical power, P, where P is electrical power. So this will be equal to 99.6 upon 100 means 0.996. P means I into V. So we get I is equal to P heating upon 0.996 into V. So pH is 600 watt, and upon 0.996 V is 50 kilovolt. So on simplifying we get the current as 0.012 ampere. Second part, velocity. Second part, E into B is equal to half mv square, which gives B as 2E into B upon m under root. Now putting the values, E 2 into 1.6 into 10 to minus 19, B is 50 into 10 to power 3 upon m 9.1 into 10 to minus 31. On simplifying, we get the velocity of electron striking anode as 1.3 into 10 to power 8 meter per second. Second question is, electrons in X-ray tube are accelerated through a potential difference of 10 kilovolt. If an electron produces one photon on striking the target, what is the minimum wavelength of resulting X-rays? Also find the velocity of electrons striking the target. Now solution. First, we know that cutoff wavelength lambda minimum is given by 12,400 angstrom divided by V. Here V is 10 kilovolt means 10,000 volt. Therefore, it will be 12,400 angstrom divided by 10 into 10 to power 3. On simplification, we get lambda minimum as 1.24 angstrom. 1.24 angstrom. Now second part, E into B will be equal to half mv square. This gives B as 2 EB upon m. 2 E upon m of electron is 1.8 into 10 to power 11 into B 10. This is 10 to power 4 volt. 10 to power 4. E by m of electron is 1.8 into 10 to power 11 coulomb per kg. So on simplification, we get it as 6 into 10 to power 7 meter per second. 6 into 10 to power 7 meter per second. Question number 3. Electrons in X-ray tube are accelerated through a potential difference of 10 kilovolt. If 0.5% of energy of electrons striking anode is used in producing X-rays and heating power produces at the rate of 720 watts. Find the number of electrons striking anode per second and the velocity of electrons striking the anode. Solution. Here 0.5% of energy of electron striking anode is used in producing X-rays, and the remaining 99.5% is converted into heat. So, according to question, heating power produced is, suppose that is P H. H means heating. This is 99.5 upon 100%, means 99.5%, which is 99.5 upon 100 into electrical power. Electrical power is I into V. So this can be written as 0.995 into I into B, because P is equal to I into B, electrical power. So I will be equal to P heating upon 0.995 into B. So pH is given to be 720 watts. So pH is 720 upon 0.995 into B is 10 to power 10 kilovolt, means 10 into 10 to power 3. But I is equal to Q upon T. This can be written as charge upon time is equal to 720. Current is equal to charge upon time, 720 upon 0.995 into 10. This is 10 to power 4. 10 to power 4. And again Q is equal to NE. So Q can be written as N into E upon this T, because I is equal to Q by T and Q is equal to N into E by T. So N upon T, we can separate it out. So this gives N upon T will be equal to 720 upon 0.995 upon 10 to power 4 upon E. E means 1.6 into 10 to minus 19. On simplification, it gives this much electrons per second. N upon T comes to be 4.59 into 10 to power 17. Now second part. E into B is equal to half mb square. This gives B as under root 2E into B upon m. E by m is known. This is 2 into 1.8 into 10 to power 11, which is E by m, and B is 10 to power 4. On simplification, we get 6 into 10 to power 7 meter per second, which is the velocity of electron striking the anode. Next question number 4 is, an X-ray tube, X-ray spectrometer has a crystal rock salt with atomic spacing 2.82 angstrom, and the spectrometer is set at an angle of 14 degree. An intense first line appears when the voltage across the tube is 9045 volt. Find Planck's constant. Now solution. From Bragg's law, from Bragg's law, 2d sin theta is equal to n lambda. Here n is 1. Here d is interatomic spacing, which is given to be 2.82 angstrom. N is 1. First line or first order. Theta is 14 degree. So we get lambda as 2d sin theta upon n. That is 2 into 2.82 into sin 14 upon n is 1. On simplification we get 1.36 angstrom. 1.36 angstrom or 1.36 into 10 to minus 10 meter. Into minus 10 meter. Now E into B is equal to HF, which is HC upon lambda. This gives H as EB into lambda upon C. Now putting the values we get E is 1.6 into 10 to minus 19, B is 9045 and EB lambda, this is EB lambda upon C. Lambda is 1.36 into 10 to minus 10 upon C means 3 into 10 to power 8. On simplification we get Planck constant as 6.56 into 10 to minus 34 joule into second. Next question number 5. An X-ray tube works at a DC potential difference of 50 kilovolt and the current through the tube is 0.5 milliampere. Find the number of electrons striking the anode per second. Second part, energy falling per second on anode as kinetic energy of electrons. And third part, cutoff wavelength of X-rays. Here given for X-rays, X-ray tube, B is 50 kilovolt, 50 into 10 to power 3 volt. Current I is equal to 0.5 milliampere, that is 0.5 into 10 to minus 3 ampere. First we have to find the number of electrons striking the anode per second. As I is equal to Q upon T, current I is equal to Q upon T and Q is equal to NE. This is NE upon T. This gives N upon T as I upon E. Therefore, N upon T will be equal to I means 0.5 into 10 to minus 3 divided by E, 1.6 into 10 to minus 19. On simplification we get 3.125 5 into 10 to power 15 electrons per second. This is this much electrons per second, first part. Second part, energy falling per second on anode will be equal to the power energy falling per second on anode. This will be equal to the power which is I into B. So I is 0.5 10 to minus 3 and B is 50 into 10 to power 3. On simplification, we get the energy falling per second on anode as 25 watt. Because this cancels this and we get 25 watts. Now third part is cutoff wavelength. Cut off wavelength will be equal to lambda minimum, which is 12,400 angstrom divided by B. B is 12,400 angstrom divided by 50 into 10 to power 3. On simplification, we get 0.248 angstrom. 0.248 angstrom. Next question number 6. X-rays are incident on the zinc sulfide crystal of crystal spacing 3.08 into 10 to minus 8 cm and the first order reflection takes place at a glancing angle of 12 degree. Calculate the wavelength of X-rays and the glancing angle for the second order. Here given for X-ray D is equal to 3.08 into 10 to minus 8 cm, which is 3.08 into 10 to minus 10 meter. This is crystal spacing. Of zinc sulfide crystal. Theta 1 is equal to 14, so 12 degree for first order n is equal to 1. We have to find wavelength lambda, and secondly for n is equal to 2 we have to find glancing angle theta 2. Solution first from Bragg's law. Two d sin theta is equal to n lambda, or you can say 2 sin theta n is equal to n lambda. Therefore, for first order 2d sin theta 1 will be equal to 1 lambda for n is equal to 1. So, lambda will be equal to 2 into d 3.08 10 to power minus 10 and sin 12. On simplification we get lambda as 1.28 into 10 to minus 10 meter or 1.28 into 8 angstrom. Now second part, for n is equal to 2, 2d sin theta, 2d sin theta will be equal to sin theta, 2 will be equal to n is equal to 2 into lambda. This gives sin theta 2 as 2 lambda upon, or this 2 can be cancelled out. So we get sin theta 2 is equal to lambda upon d, lambda by d. Hence theta 2 will be equal to sin inverse of lambda upon d, which is sin inverse lambda is 1.28 into 10 to minus 10 meter, and d is 3.08 into 10 to minus 10 meter. This cancels, and on simplification we get theta 2 as 24.56 degree. Next question number 7. X-rays of wavelength 0.36 angstrom are diffracted by Bragg's crystal spectrograph at a glancing angle of 4.8 degree. Find the spacing of atomic planes. Now, from Bragg's law, two d sin theta is equal to n lambda. For n is equal to 1, theta is equal to 4.8 degree. Therefore, d will be equal to n lambda upon 2 sin theta. N is 1, lambda is 0.36 angstrom. Lambda is 0.36 angstrom upon 2 sin 4.8 degree. On simplification we get d as 2.15 angstrom. 2.15 angstrom.